Hello, everyone. Let me get my slides up here real quick. There we go. All right, welcome to our session today. We're going to be exploring a top Redis alternative, which is Dragonfly. We'll be getting into architecture, use cases, a bit about the project. But before we jump into all of that, love to do some quick introductions. My name's Nick Gottlieb. I'm the VP of Marketing here at Dragonfly DB. And I'm joined by Roman Gershman. Roman, you give an introduction to yourself as well?
Yeah, sure. Hi, Nick. Hi everyone. I'm Roman. I'm the CTO of Dragonfly DB. And before co-founding the company and before creating the Dragonfly project, I was a principal engineer on the Elasticache team at AWS. And before that, I worked at Google and IBM.
Great. Awesome. Thanks for the introduction. So let's just quickly go over what we're going to cover in the session today. So first, we're going to go over a bit of background on the Dragonfly project, kind of how it came to be. Then we're going to review the Dragonfly architecture and how it differs from that of Redis. And then we're going to talk about where the Dragonfly project is today as a viable Redis alternative. And then finally going to do some Q&A. So if you have any questions throughout the session, drop them in as a comment and we will address questions all at the end. So to start with, Roman, I'd love for you just to tell the audience a little bit about how you came to start the Dragonfly project.
Sure. Well, while I was working on the Elasticache team, I had the chance to learn and investigate lots of issues that customers faced when running Redis at scale. And of course, not all workloads had problems, but those with performance and scalability issues were the hardest to fix. And I believe that the core problem lay in the inherent flaws of Redis design. And I discussed this with the team, with the Elasticache team. But at the end, I decided that it's going to be better just to revisit the whole design from scratch and start a new project. And that's what I did.
Got it. So wanted to kind of change things from within AWS, decided to just go start a separate project. And then you shortly after starting the project made the decision to open the code up on GitHub. Tell us a little bit about why you made that decision.
Yeah. First of all, for me, it wasn't shortly right afterwards. It was a quite painful 8 months of very intense development during COVID. For me, it was always a dream to start a community project because specifically within memory store, it has the potential to disrupt the entire memory data store market. So for me, it was an easy choice. But if you look at the developers, they want to inspect the code and ensure its quality before trying out a new project. So having a fully transparent GitHub project helps us to build this trustworthy relationship with developer community and with potential customers. And now, let's say 2 years after we launched, by the way, June 1st was like our anniversary. So 2 years after we launched, I think it was one of the best decisions we've made because now we have customers that use our managed service, and they told us that they actually tried Dragonfly community before reaching out to us. So basically, they tried this technology, they liked it, and then they decided to convert it, become our paying customers. It was a great thing to hear.
Yeah, awesome. That's the ideal kind of open source model. And then how did, there's been a lot of forks of the Redis code base over the years, people trying to make optimizations or changes here and there. How did you decide on not going that route and forking Redis and rather creating a whole new code base?
Yeah. So first of all, it was my firm belief that it is not possible to reuse the original Redis server code for multi-threaded paradigm. It just didn't fit. The implementation design wasn't built for that. And also, I thought that there are some serious design issues within Redis, and I didn't want to incorporate them into Dragonfly, of course. So we kind of built everything, almost everything from scratch. Having said that, we do reuse some low-level data structures inside Dragonfly that came from Redis codebase. For example, lists implementation or streams implementation are being reused within Dragonfly.
Got it. And for a user out there, a developer engineer who's using Redis, what does it look like to migrate from that Redis implementation to Dragonfly?
It's quite simple. Thousands of users have migrated to Dragonfly without any problem, and we have thousands of teams running Dragonfly in production. So first of all, you don't need to do any changes in your app. We made sure that Dragonfly is drop-in replacement for Redis. Secondly, we also tried to reuse the configuration flags as much as possible. And so for most common scenarios, you don't even need to change your configuration. For some specific use case, you might need to configure Dragonfly in special ways. We do have Dragonfly specific flags, of course. In that case, I just suggest that whoever wants to try out Dragonfly to check out our documentation site and see if our docs cover their use case. And of course, we have like Discord community and discourse forums. So you're welcome to ask questions as well.
Got it. So the API layer is the same, like you mentioned, so there's no need to change code. Why did you, when you were designing Dragonfly, why did you decide to adopt the same API as Redis rather than kind of implement your own?
Well, first, it's simple. We love the Redis product. I think it's very special and it's versatile. But its strength lies in its APIs. Moreover, it's not just the APIs, it's also the entire ecosystem of client libraries and frameworks. And we wanted to be part of this ecosystem. So we made this strategic decision to fully support client libraries, frameworks, and we wanted to make it as simple as possible for users of those frameworks that already run existing applications, that they will be able to switch easily from Redis to Dragonfly and instantly benefit from the performance advantages of Dragonfly.
Got it. Great. So that's thanks for sharing all that background on the Dragonfly project. I think that helps kind of paint a picture of how the project started, kind of how it's evolved. Would love to jump into some more technical details next and talk a bit about the Dragonfly architecture. And I think a great place to start is with Dragonfly versus Redis. I think, a lot of people are fairly familiar with the Redis architecture, but what are the key architectural differences between Redis and Dragonfly?
Yeah. So, as you know, Dragonfly is multi-threaded. Redis is famously single-threaded. So, for single-thread workloads, for relatively small workloads, let's say it like this, Redis is very fast. Okay. So by default, it uses a single thread and which handles everything: networking, parsing of requests, applying data store operations. All this takes, of course, CPU time. And if, for example, you have thousands of I/O connections constantly bombarding Redis with requests, or you have relatively heavy CPU operations, then your Redis instance can reach a high CPU load. And once Redis CPU becomes stressed, you can just add more CPUs to it, right? So even if your machine has plenty of them, and I mean, we are in 2024, there is no server in the world today that has a single CPU. So most likely you have plenty of them on the instance that runs Redis, and you yet still be saturated and have possibly performance problems when running medium to large to huge workloads on Redis infrastructure.
Mm-hmm.
So that's kind of the limitation, in a very hard limitation of Redis infrastructure. And if you look at the Dragonfly on this slide, you can see, first of all, it's multi-threaded, and it adopts what we call a shard per thread architecture. So you can see those shard threads on the diagram. And Dragonfly basically, by default, takes all the possible CPU power on your instance. You can, of course, control it, and it can manage as many CPU threads as you allow it. And inside its process, it has a slim and very efficient coordinator layer. And its job is to handle networking, parse requests, and decompose each Redis operation into kind of micro operations that are dispatched into these shard threads. And this coordinator layer is also multi-threaded and spread across multiple threads. So once those micro operations are executed on each thread, they return their answers to a coordinator layer, and it in turn returns the reply to a client connection. So everything is multi-threaded and everything is distributed. And that's why Dragonfly is much more scalable, vertically scalable on a single instance. And if you check out Dragonfly's detailed design, it very much resembles a very efficient pipeline where each part performs its job and then dispatches or like passes the torch to the next stage of the pipeline, and everything works very smoothly and optimized for throughput and low latency.
Mm-hmm. Got it. So that makes a lot of sense, and I think most Redis users are familiar with the fact that Redis can scale, horizontally to multiple threads via Redis cluster. How does Dragonfly's kind of model that you just described with multi-threading on a single instance differ from Redis cluster?
Yeah, great question. Actually, if you look even at this diagram of Dragonfly, it probably very much similar to a typical diagram of Redis cluster. So what's the difference, right? A totally valid question to ask. So there are many things that differ. Let's start with more important ones. So Redis has the original single node. Redis has the notion of multi-key operations that are strongly consistent and atomic. It also has transactions and support for Lua scripts. So Dragonfly supports all this on multiple threads. So you are able to run multi-key operations that spread across multiple shard threads. And it's totally and fully atomic, fully consistent, same semantics as the original single node Redis. Also, Dragonfly handles the memory capacities in a fully transparent way. So you don't need to manage each shard capacity. In fact, you don't need to manage nothing in those shards. It's fully transparent, and you only have a single process. With Redis cluster, on the other hand, like with any kind of data store database, you must provision your memory capacity for each shard. So let's say you run Redis cluster on the same instance, like with multiple CPUs, then each shard will be limited in advance by the memory that it consumes. And in case there is imbalance in memory usage, you won't be able to benefit from it. You'll have to kind of provision your whole system by the shard that uses most memory. Okay, because you'll never know where like your maximum usage will be between shards. You can't use multi-queue operations efficiently on Redis cluster. All this kind of limits and creates lots of complexity when managing Redis clusters. So Dragonfly, in that sense, much more efficient and simpler to run.
Got it. Great. Thanks for walking through all that. I think that makes kind of the differences super clear. So what I'd love for you to explain next is what is this multi-threaded model, this architecture that you just kind of described with Dragonfly? What does this actually enable an operator of that infrastructure to do? Like, how does it actually benefit the operator?
Yeah. So first of all, you need to understand the complexity involved, or what kind of technical problem you tried to solve. So the challenge was how we introduce a multi-threaded architecture that scales well with to very high throughput, scales well on multiple cores, and still preserve very low latency, so sub-millisecond latency, and also provides the same consistency and atomicity guarantees like with a single-threaded Redis. These three conditions do not work well together. It's very fast. Original Redis is very fast. So basically, once you want to provide a consistent atomicity, it creates contention between threads. So that was the technical challenge. And we succeeded to build within Dragonfly a scalable system that handles everything much faster, including multi-queue operations, transactions, and running Lua scripts. And that's Dragonfly's unique edge. And I just wanted to kind of compare a little bit other multi-threaded systems that exist today. So take KDB, for example. It's another Redis fork, also very popular. It was introduced several years before we created Dragonfly. And the architecture doesn't scale very well for multi-key operations or for running multiple Lua operations. So there is quite a bit contention when you run such workloads. And the same holds for Garnet. Garnet is a very recent project that was released just a few months ago by Microsoft Research. And they gave up on Lua support or atomic multi-key operations right from the start in order to provide a scalable solution for their architecture. So they just explicitly state in their documentation that atomic multi-key operations are not supported by default, and they do not support Lua. So Dragonfly is unique in that sense that it put this goal of being fully compatible with single-threaded Redis, and it achieves this goal while still being very much scalable.
Great. I'd like to change gears just a little bit. We've gone deep into kind of the Dragonfly architecture, but at the end of the day, you know, most engineers, most operators, most organizations, they choose their technology based on business value and how it kind of solves business problems. What is the actual values that Dragonfly as a technology delivers to its users?
Yeah, it boosts the performance. A single Dragonfly instance can reach up to 30 times more throughput than a single Redis instance. In addition, it reduces P99 latencies especially for CPU-intensive workloads. It also dramatically reduces cost due to the more efficient data structures. We can regularly see 50% reduction in infrastructure costs when running Dragonfly instead of Redis processes. And we've seen up to 70% reduction in cost for some customers. Lastly, it's a much simpler system to operate, and it dramatically reduces the total cost of ownership. And by the way, if you don't know, we also opened up an access to our managed service, Dragonfly Cloud. You can register on our site and just check it out yourself. I can say that even if you even look at just community traction, some of our community users told us that in some extreme examples, they succeeded to replace a 128 shard Redis cluster with a huge single Redis process. But again, with managed service, you just reduce your costs.
Great. Let's shift gears again a little bit to talk about the project today and kind of where it's at as a Redis replacement. So yeah, can you just give us kind of an overview of the current state of the Dragonfly project?
Yeah, sure. Well, we released Dragonfly in general availability, Dragonfly community, more than a year ago in March 2023. And since that, we worked on adding more commands. Now we support more than 250 commands. That includes some of the most popular Redis modules as well. So basically, we have vector search in alpha stage. We have JSON search that is used already by many teams in production. We have, of course, a very healthy community. We almost reached 25,000 stars on GitHub. We have thousands of teams running Dragonfly in production. And as I said, we built also Dragonfly Cloud, and we already have dozens of customers using our managed service solution. And we are going to release it into GA very soon. Lots of things has been done since last year.
Awesome. And lastly, I want to talk a little bit about the Redis licensing change. This is obviously, the Redis changed their licensing model a few months ago. It was kind of big news in the community. How does the licensing change by Redis affect Dragonfly, if at all?
Well, we've definitely seen a surge in interest in Dragonfly since that licensing change was announced back in March. But for us as a company, it didn't really change much. We're still focused on building the best in-memory data store for modern applications. But if you kind of think about Redis community, it has been split now into two projects, Valky and Redis. The Valky project, which is now a Redis fork, is backed up by the cloud providers under the Linux Foundation umbrella. It didn't change much since the split. Besides branding, of course, we'll yet need to see how this project will evolve. And with Redis project, it's of course supported by the Redis company. At this point, there is not much. Also, we released, I think, one feature since the split. So we will continue to follow up on these developments and basically see how we adapt with this new change. I can say that our goal is to be part of the Redis ecosystem, meaning to support all those frameworks and client libraries that use the original Redis. So it doesn't really matter to us as well as long as we are kind of compatible with the whole ecosystem.
Mm-hmm. Great. Thanks so much for walking us through all of that, Roman. I think that paints a really good picture of kind of where Dragonfly came from, what the differences are between it and Redis, where the project is today. Would love to turn next to the audience and just see if there's any questions that Roman can answer based on the content here or anything else. So I'm going to check real quick in the comments to see if we have any questions. Give everyone just a minute to see if there's anything coming in. All right, well, if there's no questions, I think we'll go ahead and wrap up for today. Thank you everyone for joining and learning a bit more about Dragonfly. Like Roman mentioned, you can check it out on GitHub, download and host it or run it on your machine for free. If you want to check out our managed service, you can go to dragonflydb.io and sign up for free there. So thanks everyone and take care.
Thank you.